Hello students, welcome to my class. Today I am going to discuss few questions related to JEE main exam pattern. As I told you earlier, my chapter is nuclear chemistry because in my last lecture I discussed the question related to NEET exam pattern also. So, and this chapter is completely calculative based, and this topics related to this chapter also touches the chapter chemical kinetics also, because in chemical kinetics we also study about the order of reaction, and we all know nuclear chemistry, that is the base, that is radioactivity, completely radioactive disintegration follow first order kinetics. Clear my friend? So let's start the question. Check it out which type of questions are frequently asked in competitive examination related to this chapter. Wait for a moment friend. Now look at the first question is given here, the emission of beta particles by an atom. What the question here is? Emission of beta particles by an atom of an element result in the formation of. That is the question. Beta particle. Wait. That is the solution of this question is, as we know, if a beta particle emits, then what will happen? If a parent atom, or you can say nucleus, have mass number A and atomic number Z, and the emission of beta particle leads to the unchange in the mass number, but there is one increment, the atomic number increased by 1 due to the emission of one beta particle. This is the general concept, my friend. Yes sir. Now check out, given emission of beta particle by an atom of an element result in the formation of, look at, this is parent, this is daughter, A and A, that is mass number is same but atomic number differ. If mass number remains same, atomic number differ, then we people know they form isobars. Clear? This is the concept, isobar. Now for this we people can say the answer is A, isobar. Clear my friend? Now I am rubbing this part. Now the next one is the isotope of 23592 U decay in a number of step to an isotope of 20782 Pb. The group of particles emitted in the process. Now how many particles emit in the process? That is, the solution is, that is U 235 and 92, that is the initial. Now what is the final product in this case? That is Pb 20782. Now in this case they are asking how many alpha and beta particle emitted during the conversion of uranium to Pb. Now first of all, what to do? Find it out, decrease in mass number. What is the decrease in mass number? 235 minus 207, that is 28. Good problem? Now decrease in atomic number, that is equal to 92 minus 82, that is equal to 10. Am I right? If there is a decrease in mass number 28, then definitely we people know only alpha particle brings the decrement in the mass number. So the number of alpha particles emitted that will be equal to 28 divided by 4, that is equal to 7. Am I right? Yes, sir. That is, we can easily say the number of alpha particle emitted is 7. Now the case, if the alpha particle emitted, then what will be the actual decrease in atomic number in this case? So the actual decrease in atomic number will be 92 minus, if there is a emission of 1 alpha particle take place and there is a decrement in atomic number by 2, here is 7 alpha particles, 7 to the 14, 92 minus 14, that will be equal to 78. Clear, my friend? That is equal to 78. That is, the actual atomic number of parent element should be, that is 78, and the mass number should be, that is 207. But here what we observe, the atomic number here is not 78, it is 82, that is plus 4. Clear? If that is difference, that is 4, that means to say this 4 is the this 4 symbolize that there is an emission of beta particle also take place. How many beta particles? Sir, 4 beta particles. Why? Because the emission of beta particle increases the atomic number, my friend, by 1. 4 beta particle, 4. So in this case we can say the number of beta particles emitted, beta particles emitted is equal to, my friend, 4. So what is the answer in this case? 7 alpha and 4 beta. Now check out which is the correct option, that is 7 alpha and 4 beta. So for question number 2, C is the correct option. Clear? Now let's move to the next question. Look at what is the question. Check it out what is given here. That is, the number of alpha particle emitted per second by 1 gram of radium is 3.7 into 10 to the power 10. The decay constant is. Here is given, you have to find out the value of decay constant. Now how to solve such question? Tell me. The solution of this question is, as we know decay constant is alpha. Alpha will be equal to number of disintegration per second per second, yes sir, upon total number of atoms. Am I right? Yes sir. That is, lambda is equal to number of disintegration per second upon total number of atom. What is given here? Number of disintegration per second is 3.7 into 10 to the power 10, my friend, divided by, and what is Ra? 1 gram. Clear to you? That is, how many atoms in 1 gram? We people know 226 gram contains 6.022 into 10 to the power 23 atom. So 1 gram will contain, that is 6.022 into 10 to the power 23 divided by 226. In 1 gram, that is the number of atoms. So put this value here, you will get the output. So decay constant lambda is equal to 3.7 into 10 to the power 10 divided by 6.022 into 10 to the power 23 divided by 226. This is the question over here. Now and this is decay constant. After solving, what do we get? We get the answer around 1.39 into 10 to the power minus 11 per second. So for this question, we can say A is the correct option. For question number 3, A is the correct option. Now I'm going to rub this part and we'll discuss the next one. Wait for a moment. Now, the question number 4. A sample of 1419K contains invariable 1418 AR. This is because 1419K has a tendency to undergo. Which one? Look at 1419K has N is equal to, tell me friend, that is 21, 14 minus 19. And P is equal to 19. Definitely. Here the N by P ratio is 21 upon 19. Now it converts to 4018 argon. Here the number of proton is 18 and the number of neutron is, my friend, 22. In this case, N by P ratio will be 22 upon 18. Look at, if we compare the N by P ratio, it will have less value and it will have more value. That is, the N by P ratio increases when K converts to AR. That we people know, if N by P ratio is going to increase, and in this case which type of emission take place, as I discussed in my lecture, that is cause of radioactivity, that is the answer will be positron emission. In this case what will happen, that is the positron decay take place. Clear? Beta decay, in this case if N by P ratio is higher and we have to reduce the N by P ratio to a stable limit, then in this case beta decay take place. And what about alpha decay? In case of natural process, and when same case when N by P ratio is lower and we have to increase the value of N by P ratio, my friend. Clear to you? If you have any doubt, you can easily ask me. Look at here, check it out, N by P ratio less, N by P ratio more. From lower to higher, that is the positron emission. So in this case, the question number 4 has B option, which is correct. Now let's move to the next one. What is the next one? Check it out. The next one is question number 5. Look at, this is complete calculative type question, and what is given here? 14C has a half-life of 5760 year. 100 milligram of sample containing 14C is reduced to 25 milligram. That is, according to the question, what is given here? That is T half, my friend, is 5760 year. Clear to you? And N naught is equal to 100 milligram. And N is equal to 25 milligram. Clear, my friend? Yes. And what is given here? That is, we have to find out the overall T. How many times? Clear? As we know, lambda is equal to 2.303 upon T log N naught upon N. This is the thing. What is lambda? We people know lambda is equal to 0.693 upon T half is equal to 2.303 upon T log N naught is 100, N is 25. That will be cancel each other, the 4. Clear, my friend? Now what is T half? So in this case I am moving here, that is 0.693 upon T half. That T half is 5760 year and equal to 2.303 upon T log 4. Log 4 can be written like this, 2 to the power 2. That will be equal to that is 0.693 upon 5760 is equal to 2.303 upon T into 2 log 2. Put the value of log 2, that is 0.3010. I think now you can easily solve this calculation. You get the value of T, which is, I'm moving here, which is 11520 year. That is A is the correct option, my friend. Clear? Now I am going to rub this part and we'll discuss the next question. Wait for a moment. Now, question number 6. Look at, a radioisotope has half-life 10 days. What is given here? A radioisotope has half-life 10 days. Given here, T half is equal to 10 days. Clear? If today there is 125 gram of its left, what was its mass 40 days earlier? Today, listen carefully, this is slight tricky question. Today 125 gram, okay, half life is 10 days. So before 10 days what will happen? How much amount? Before 10 days, just double, because half life is 10 days. So 250 gram, yes sir. Then before 20 days, tell me, it will be equal to 50 gram, 500 gram, pardon friend. Then before 30 days, what will happen? Tell me. That is 1000 gram, and before 40 days will be equal to 2000 gram. So 40 days earlier the quantity is 2000 gram, my friend. This is the normal. Now the next method is, as we know, n is equal to 1 by T to the power n into n naught. Am I right? Yes. And by using this also you can find out the value. Here is n is given 125. 1 by 2 to the power n into n naught. We do not know the n. We know T is equal to T half into n, and T is given here 40 and T half is 10 into n. Clear? So 40 upon 10 is equal to n, that is 4. N is equal to here 4. So put this value of n here, you will get the answer. So what will happen? 1 by 125 is equal to 1 by 2 to the power 4 into n naught. Now 1 by 2 to the power 4, what will happen in this case? That is 16. Yes sir, that is 125 into 16 is equal to n naught. I hope so. 125 into 16 will be equal to 125 into 6. 750, 1250, that is 2000. So the answer in this case is also 2000 gram. So whatever the technique, you can get the answer. The answer in this case, my friend, that is 2000 gram. For question number 6, we people say the answer is 2000 gram. I hope now you can easily solve such kind of questions. Wait for a moment, give me few seconds. I think definitely it will help you a lot. Question number 7. Now, the first stable isotope which was transmuted by artificial mean. This is a theory where first isotope transmitted by that is transmuted by artificial mean, that is the B option, that is nitrogen. 7, 14 nitrogen. So for question number 7, we people say that is B is the correct option. Now let's move to the question number 8. 2713 Al is a stable isotope. 2913 Al is expected to descend. Look at, first of all, in this case 2713 stable nucleus, that is 2913 Al is going to convert in 2713 Al. Now check out the N. N here is, tell me. So N here is 29 minus 13, that is 16, and P here is 13, and here is N is equal to 14, 27 minus, and P is equal to 13. Now check out here, N by P is 16 by 3 upon 13, not 3, and here N by P is equal to 14 upon 13. Look at here. That is, the parent has high value of N by P ratio, that is we are reducing the N by P value to gain the stability. Again, cause of radioactivity, if the N by P ratio is higher than the stability, to reduce the N by P ratio in case of daughter element, what to do? That is the beta emission take place. So in this case, what will be the answer for question number 8? B is the correct option, my friend. Okay, now let's move to the next question. What I am telling, listen carefully. The nuclear reaction is referred to this type of reaction when a bigger one breaks into different type of nucleus. In this case, we require a projection of around 40 mega electron volt, and this type of reaction is known as spallation reaction. Clear to you? These are the type of reaction. First one is projectile absorb reaction, second one is particle reaction, third one is spallation reaction, fourth one is fission reaction, fifth one is fusion reaction, and the last one is chain reaction. So in this case, this reaction is known as spallation. The reaction, the nuclear reaction, which is initiated by a projectile having 4 mega electron volt, and that is the energy requirement, around 40 mega electron volt, and the product take place in this case, that is bigger one converted to smaller one. But this is not, my friend, is fusion reaction, this is spallation, so don't get confused. Clear? Now I'm going to rub this part and we'll discuss the next one. The next one, last question. 238 uranium 92, that is the atomic number is 92 and the mass number is 238. That is Z is 92 and A is 238. Clear? And emits 8 alpha particle, 8 alpha. Clear to you? In this case, what will happen? The mass number decrease by 4. 8 into 4, that is 32. Yes, sir. And 6 beta particle. 6 beta particle, what will happen? That is atomic number increase by 6. Definitely. If 8 alpha particle, then the atomic number decrease by 8 to 8 into 2, that is 16. Clear? 16, and overall decrease in atomic number minus 16 plus 6, that is minus 10. So the daughter element have mass number, that is daughter element is Y, and 238 minus 32, that will be equal to 206, and 92 minus 10, that is 82. This is, and we know this is nothing, that is PB, 20682 PB, my friend. Now the given the neutron proton ratio in the product nucleus. Neutron proton, as we know, number of proton is 82, number of neutron is 206 minus 82, and what will happen? 206 minus 82, that is 4, and that is 2, that is 124. Am I right? Yes, sir. That is, put here N is equal to 124. 4 to 6, 8 to 10, 112, 124. So what is the ratio of N by P in this case? 124 minus 82 upon, 82. Now what will happen? 41. And here 62. 62 upon 41 is it given here? Yes. 62 upon 41. So for question number 10, C is the correct option, my friend. I think now you are very much familiar with such kind of question, and it will boost you a lot. And this chapter also cover the few part of physics also, that is the nuclear physics. So if you compare them, there is slight difference as per the content, but the things always same. Now review the things. For question number 1, what will be the answer? That is A. For question number 1, A is the correct option. For question number 2, what was the answer, friend? C. Yes, definitely, I think so, C. That is 2C, because I have given you a complete technique to solve this question. For question number 3, A is the correct option, my friend. Now for question number 4, that is positron decay, B is the correct option. For question number 5, A is the correct option, 11520 years. For question number 6, what is the correct option? D is the correct option. For question number 7, that is B, that is nitrogen, 147. For question number 8, stable isotope expected to disintegrate by beta emission, B is the correct option. For question number 9, that is spallation reaction, A is the correct option. And for question number 10, C is the correct option, 62/41. Now I think you can easily solve such kind of question. So this was the few question related to JEE main exam pattern. Okay friend, so time to say bye bye. Thank you so much.